In this video, we're going to look at very similar to what we did in the previous two videos of, uh, parallel lines and transversals. This is the same stuff, but we're kind of working backward this time. So instead of us telling you that the lines are parallel, you have to prove that they indeed are parallel. So I've got an example here. It says our lines P and Q parallel. And then I've got lines P and Q cut by a transversal. And then this angle's 23, and this angle's 23. And so what we've learned about parallel lines and transversals is that if the alternate exterior angles are congruent, or pardon me, if these lines are parallel, then the alternate exterior angles are congruent. Well, vice versa. If the alternate exterior angles are congruent, then the lines have to be parallel. So I kind of wrote that out here. Lines P and Q are parallel because the alternate exterior angles are congruent. And then second sentence kind of redundant, but it says if alternate exterior angles are congruent, then the lines have to be parallel. So it works both ways. If you know the alternate exterior angles are the same, then the lines have to be parallel. And then if the lines are parallel, the alternate exterior angles have to be the same or congruent. Okay, so this is kind of the essence of today's video. So let's look at two more examples, and they of course get progressively more difficult. And so here's another example. It asks, are lines M and N parallel? So the 146 and the 44, they are not any special types of angles. But what we could do is we could say, we could do corresponding angles, we could do vertical angles. So I know that if this is 44, then I know that this is also 44 down here, because these are vertical angles. So that is true. That's for sure. So the other thing that I need to prove is if M and N are parallel, then 44 and 146 must be supplementary. These angles in here, those are called same side interior. So let's write that down here. Same side interior. So if 44 and 146 are same side interior angles, and if we want to show that these two lines are parallel, then these two angles have to add up to 180 because they have to be supplementary. So let's add those up. So I'll grab my pen and I'll go 44 plus 146. And guess what? We get 180. Oh, not 180. We get 190 in this case. So these two add up to 190. And that tells me that since the same side interior angles are not congruent, then lines M and N are not parallel. So if I were writing this out, and to spare myself my penmanship here, I would write lines M and N are not parallel. M and N are not parallel because the same side interior angles are not supplementary. So if you're writing out a solution to a problem like this, this is how you should phrase it. And then we do know that these two angles are congruent because they are vertical angles, and that has to be true. All vertical angles are congruent, so these two are the same. And then since the 44 and 146 don't add up to 180, then that means lines M and N are not parallel. Okay, one more example, and of course, why not throw some algebra in there? So this tells you that this is 33 degrees right here, this angle. The angle next to it is 12x plus 12, and the angle down here is 3x plus 18. So there are a few different ways to do this problem. One way is we could say, well, these two have to add up to 180 because they're a linear pair. Another way I could do kind of like I did last time, where I know if this is 12x plus 12, then this angle down here is also 12x plus 12, and likewise, just a refresher, the angles across from each other, these vertical angles are both 33 degrees. So maybe let's do that. If we know that this is 12x plus 12, and this is 3x plus 18, well, these two have to add up to 180, just like we did in the previous one. Or we could say that if this is 33, this also has to be 33, so these have to be the same. We could solve for x there. It doesn't matter which route you want to take. You just have to say, well, the 3x plus 18, I need to compare it to something over here. So I'm going to do the same thing that I did before. I'll do 12x plus 12, this one plus this one has to equal 180. So let's write that out here. So I'll grab my pen. I'll do it in blue this time. So 12x plus 12 plus 3x plus 18 equals 180. So if this is the case, let's solve for x. We get 12x plus 3x on the left side of the equal sign. That's 15x. And we get plus 12 and plus 18 on the left side of the equal sign. That's plus 30 equals 180. So then I would solve, I would subtract 30 from both sides. And we get 15x equals 150. And then divide by 15. And we get x equals 10. Okay, so this doesn't tell us if they're parallel or not, but it does help us prove that they are or are not parallel. So we know x is 10. Let's plug that into these two and see what these angle measures are. All right, so let's go 3 times 10 plus 18. So that'd be 30 plus 18, because 3 times 10 is 30. So we get 48 degrees for this angle. Okay? And then over here, if we've found that x is 10, then we get 12 times 10, that's 120, plus 12, and that's 132. And 132 plus 48, that does equal 180, and it should, because that's how we figured out what x is. But now what we need to do is, if this angle is 132, does it make sense that this one is 33? So the thing is, these linear pair right next to each other, they have to add up to 180. So my question is 132 plus 33 equal to 180? And the answer is no. 2 plus 3 is 5, so then we get 165. So it does not equal 180. So our lines A and B parallel, this is A and B, sorry, I forgot to label that. So our lines A and B parallel? No, these are not parallel, because if you set up the same side interior angles and solve for x, because you know they have to be supplementary, then it doesn't allow the linear pair to be supplementary. And so since the linear pair is not supplementary once you solve for x, then that tells us that this falls apart and the two lines are not parallel. Okay, one more quick example. I forgot to make this one up, so we'll make it up on the fly. So let's say we've got two pairs of lines that look like they're parallel. Something like a pound sign. So I want to know which of these lines are parallel. So let's just do some labeling here. So draw this out, and we'll call this, I don't know, x and y. And we'll call this W and V. And if this, we'll say this is 50 degrees. We'll say this one is also 50 degrees. And this one is 120 degrees. Okay, my question is, which lines are parallel? So is x parallel to y? Or is W parallel to V? Or both? Are they, do we have two pairs of parallel lines here? Okay, so if I just focus, I'll grab my little magic pen here, and if I just focus on this section right here, that's not working the way I want it to. So I'll try it again. So let's just use a regular pen. So if I just focus on this area right here, I have two lines that are parallel, cut by a transversal. If these are both 50, then that tells us that W and V are parallel lines. So is W parallel to V? Yes. And how do we know? Because these two angles are corresponding angles, and the corresponding angles are congruent. So we'll write the corresponding angles are congruent. Okay, so we've proved that so far. Now let's look at the other side. So let me just kind of get rid of this little mark I have here. So that's a 120. We'll fix that in a minute. And so we showed that W and V are parallel. Now let's say, what about X and Y? So I just want to focus in on, let's see, we'll fix the 120 here. And I just want to focus on this section right here. So we've got two lines cut by a transversal. And if this is 120, then that means the one next to it has to make it add up to 180. They're supplementary. So that tells me that this angle right next to the 120 is 60 degrees, because 60 plus 120 is 180. Now, if we've got a 60 here and a 50 here, these are corresponding angles, and those are not the same. That means that X is not parallel to Y. So, and we know it's not because the corresponding angles are not congruent. So the corresponding angles are not congruent. Oops. And so this proves then that only W and V are parallel and X and Y are not parallel. All right, so there's a few examples of proving lines parallel.